It's so good to have all of you here. Obviously, we've had a little resolved. It's so great to be here to celebrate this pre-eclipse event. And all this started because our Vacation Bible School last year was astronomy based. And we, as that wrapped up, started talking about the eclipse, a large team of folks making all this come together. So start out with the kids singing the song from the Stellar VBS. So all those of you young people, and if you would just like to come up and sing with the kids, and we're going to get that running here in just a moment. Okay, why don't you hold the splitter? Hold the splitter and just directly here. All right, guys, if you remember the song really well, that's great. And if not, it should be coming up on the screen right over there. Okay?
Yeah, yeah, let's slide. Yeah, yeah, show me your heart. Slide. Yeah, yeah, shine, slide, for all the world to see, all the world to see. Every single day is another jump to the left. Yeah, yeah, let's jump to the right. Yeah, yeah, let's do the airplane. Yeah, shine, slide, shine, slide. Every single day is another chance. Every time you laugh, every time you shout, even when you're quiet. High, shine the light of Jesus, shine it bright, shine it bright. Every time you laugh, lift it high, shine the light of Jesus, shine it bright. For all the world to see, shine Jesus' light. Shine His light, for all the world to see. Every single day.
Back, they were singing that and doing those motions back from last year's vacation. Opportunity to sign up for this coming Vacation Bible School, which is happening in June, and do that when you're downstairs. We want to welcome all of you once again to. Okay, so what is an eclipse? An eclipse is when one astronomical body blocks the light from another one. So we're going to do a little exercise to help you understand kind of how that works. You close one of your eyes and take your thumb and put it, right? You may have to pull your thumb in depending if you're close, or you could probably hold it out if you're at the back. Now, is your reflected light of my face from you being able to see it? So you are eclipsed. Now, if you do the same thing, move it slightly to the side. Okay, when the alignment isn't quite lined up perfectly. And is so much smaller than the sun. If it's not lined up perfectly, we don't get a total eclipse. But we may get a partial eclipse or an annular. Afternoon, it starts just before 2 o'clock across the face of the sun, and for that brief period where it's totally blocking. All right, so here are some graphics, and the sun is 150-ish miles wide, 70 at the smaller side, and that's the whole distance of the eclipse. The other kind of eclipse is a lunar eclipse, blocked by the Earth. And because the Earth's shadow compared to the moon is so much bigger, and you see, often it looks like the moon is red. And that's because at dawn or at sunset, the sky, kind of red, right? Well, and that's the light that makes it around. The atmosphere is bending that light around, and so it can be pink. If there's been a big volcanic eruption somewhere recently, it can be dark green. I need some kid volunteers. I need 3 volunteers. There is one right there. There is one right here. And one right there. It's the multiplication of, we could have the sun here, sun over here. Okay, so the sun is shining, and the sun is always shining. We have the earth and we have the moon, okay? And so these 2 different kinds of eclipses happen at different, it's always a full moon because it has to get the whole sun. So if you can move a little bit, okay? And you guys turn your earth to face here. There we go. Okay, so the sunlight's coming, right? The earth makes a shadow, and it blocks the light of the full. Now I need you to go to the other side of the earth, please. All right. And what's the other side of that moon? Right, because a total solar eclipse only happens. The moon's orbit is tipped to our orbit around, and those rings line up exactly right for a total solar eclipse area. So we have the moon blocking, can't get to spots on the earth, and that's how we get a total solar eclipse. Okay. Of the eclipse across the country, it's one of the great American eclipses that kind of in Illinois, right? Went that direction. This one starts out in the Pacific, and it goes this, which is a reminder that it's just the circle of the moon, that shadow that is moving across. So depending down the road, you could say, look, I watched the shadow go all the way down with your car. Does that make sense? The shadow of the moon is moving this way, starting out at about 2,000, and by the time it gets over here, I don't know if you can see these start smearing out. It's which is one of the reasons that because of the rotation of the Earth and all of those things come into play. Here, it happens to go right through where we are, which is totally amazing, right? Okay, Dr. Litter, can we have the next one? There we go. You can see up close, this is the path around, and north of this bottom line is in the area of totality, which means we get the live in Sylvania. Nope. And the difference between 98% covered and 100% covered is actually pretty massive because the sun is so bright. So anybody who lives north of the Toledo-Fort Wayne line or south of partial eclipse, anybody who is in the center here has a chance if the clouds aren't there. Okay? Next one. All right, so here is out to Professor Laird, who let me borrow a part of an Eclipse PowerPoint that he had already made, so he had so many more cool graphics than I could find. Here is the timeline. In front of the sun here keeps moving across, and you notice here, and this is not just highlighting, right? This is called the corona. And the sun is totally blocked because the sun's photosphere and chromosphere are so bright that the light overwhelms this faint corona. One of the only times you will ever get a chance to see part of the sun. And we're hoping, because the sun is in, this will be exciting. And then it's only for those few minutes that's happening. So like it says here, 3 closer to 310 to 312, 313 Marysburg. If you are right down in the center, you get close to 4 minutes. I'm driving to Bloomington to go see Mariah, and Bloomington is right in the middle. And so there are going to be almost 4 minutes there, so it's very exciting. And then after that, it's so brief is the same reason that you could only block my face with your thumb. The moon is 400 times smaller in diameter than the sun is. I know they learn to be accurate would have needed to have been wide, which is amazing, right? But closer to the earth than the sun is. And so because of that, they line up. The only safe time to look with your eyes at the eclipse is right here during totality, right when all out. During those few minutes, it is safe to look at the sun and see what's going on. During these times, even here when it's just a crescent at the sun. There are safe ways to do it. One of them Everybody here, we have a bag for every family that has 2 pairs. Are a little bit fragile and you don't want any rips or tears in them. And we have, okay? So that is one safe hole projection, which you just take a box, a rectangle over it, and literally use a pin and make a hole in it. At the inside of the box, put a piece of white paper, and then cut another hole in the opposite side to look through and project it onto the white paper, and you'll be able to watch this safely because you're only looking at the reflect. That many trees that are leafed out here that well, but if the trees with the colander, not a straining kind, but the kind with the little holes in the bottom, a piece of cardboard and a hole punch, put a couple hole punches in that, hold it over your head, and you will project it on. To look at it safely, Eclipse glasses, looking at indirectly. Okay? Next. Once in a lifetime event. The last time there was a total solar, so your great grandparents were just born. Though not always, but about every 3 years where those rings line up so they, but they can be in the middle of the ocean or down in Antarctica or up in the Arctic or somewhere else, and it's only a limited seen by the whole night side of the planet. A solar eclipse is only that little track. Some interesting things on motion end up being these small curves that only cover. Is not until in Northwest Ohio isn't until 2099. So most of you in here will not be around to see it. Here's the reason why it's so important. Burned retinas, which is the part of the back of your eye that does the seeing, burned retinas do not heal. Let me say it again. Burned retinas don't. Eclipse, you will burn your retina in a matter of seconds because in your eye, if you've ever held a magnifying glass between the sun and a dry wall and seen what happens almost instantly when you get that focused right, your eye and it will focus that light onto your retina and burn it. If you look at it very long, it will burn a hole in it and you will never regain sight in that area again. If you are looking the wrong way, you will lose the center of your sight for the rest of your life. So don't. All right? Care, and this is how we are trying to care for one another. Use Eclipse glasses or that pin, a colander or a punch card to look at it on the ground. Amazing. You could also, if you have a telescope that has a solar filter on it, you can look at it through there and see it even better. At the end of things today, there'll be an opportunity to do that out in the parking lot. For those of you who are still next. Ta-da! Eclipse glasses again available for anybody who is here today, and extra ones available for the rest of your family or friends and neighbors. Next one. We already covered that. Okay. We have a lunch downstairs in the FLC, and there are activity tables, all kinds of different activities down there. We only have And there are more than that of you here. So we are having 2 question and answer sessions with Dr. Laird and myself, which we will attempt to answer all of you. There's one that's going to immediately follow this, and another one that will be at 12:45. The Eclipse glasses are available at the welcome desk. That's where you can pick up your bag that has them. All right. I'd like to invite Pastor Melanie forward, and she's going to do lunch for their first session rather than staying here for the first session. We'll be able to start right away on their food and not have to wait for us to get down there.
Okay, who knows the Johnny Seed prayer? Hello? Okay, I'm back on. Okay, great. I saw several hands. We're not going to sing, but no, yes. Wow, this is mixed reviews. The Lord is good to me, and so I thank the Lord for giving me the things I need, the sun and the moon and everything. And then, okay. Oh, for giving me the things, the sun and the moon and everything, the Lord to me. Amen. 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 Good job, guys.
No, it's just a bonus for people staying. All right, it will just take us a few moments. Answer time. Thank you so much for being here. We would like to encourage you to come for our conversation, and as an incentive for that, hidden in the front section, prizes. For those of you who stayed and didn't say, I'm going to go eat first, and are willing to sit in the front. So it's an opportunity.
Thank you.
Professor John Laird, who is Professor Emeritus of Astronomy at We are blessed not only to have him here, but have him be a part of. So it is great, and it lined up so perfectly with this, too.
It did. Well, in the case of the sun rising and setting, it's simply the rotation of the Earth that does that. The moon is revolving around us. So it's really the moon's motion that dominates an hour that the shadow moves. It would be even faster if the Earth were sitting still and not rotating in its orbit that controls the motion and makes it go west to east.
Can the Eclipse glasses be worn over regular glasses?
You may want to wear them on the inside or on the outside, depending on how they're going to fit. And we have too big for their faces, and so we have an activity station downstairs where paper plate mask so that their faces are covered, and so when they're looking, they can also safely look at them.
Glasses do is cut down the amount of light, so you'll still want whatever correction you have in your glasses to be able to see well.
Please.
The time graphs that I see in the shadow have little feather shapes in it. I'm wondering what the explanation is for the feather.
I am not entirely sure.
My guess is that it's simply the way, again, the shadow is a circle, so they're all circles together, and maybe it's something that has to do with that shape. There isn't anything in the moon's shadow that creates that feather effect, so I think it's something in the way. Where are we here?
Could you expand your comments on looking at the sun when there's no eclipse and perhaps comparing some differences?
Yeah, the sun is 93 million miles away, and it still makes the Earth. There's that much radiation coming at us, and time is not a great thing. And most of us, when we were little kids, but we are more tempted to, because there's stuff going on. Usually, it's just a disk, and during the eclipse, there's so you can see it easily with the naked eye. But if you are looking without the glasses on, so that's why it's just so important. And one of the things that we wanted was to be safe around this, because there's just
Some expansion or comment on the electromagnetic spectrum. Is it some part of the electromagnetic spectrum that causes the burning?
It's really just the amount of visible light. It's visible light that is getting through the atmosphere, and it's just the fact that it's so highly focused.
And
So it's not the wavelength per se. not the part of the spectrum, just the.
It's the heat that burns the retina versus,
When the light is that concentrated, it focused that it's not just the infrared, the optical light is so intense.
Something.
It's a little bit different from that in the sense that your eye is sensitive to visible light. Well, it's a chemical reaction that's happening in there. All of the molecules are just, all of the molecules in the retina. And that's what's happening. So it's not a physical burning. The visible light is creating a chemical reaction.
To give you an idea, the Eclipse glasses cut down the amount of light by about 100,000 times.
Yeah, Eclipse glasses only let between 1 and 3 thousandths of light through compared to the light that's just out there.
The article I read said it's 99.
Less there's going to as the I think the danger is going to be as the disk is swung that is going to, because there's less light. I mean, you can't when the sun is going to, am I right, as it becomes darker, it might be easier to look up.
Physical reaction to turn away from it, to shut your eyes, is slightly reduced. And that reaction is still going to set in some, but you tend to want to overcome it a little bit. The other thing that makes it worse is that as the amount of light decreases both ways.
What are we going to be? What are we going to be able to see during totality surrounding the whole affair? Will there be stars? Will there be planets visible to us?
Well, there will be a sunset, but not for a number of hours after the eclipse, I predict. Definitely look for, if this is the sun, Jupiter is up here, and Venus is down here toward the horizon. Venus, if you use a fist measurement, and your fist held at arm's length is Jupiter is about 2 fists up, and it's about 1.5 fists down. So those are the two to look for. All of the other planets are in a line, and more or less, I guess Mars and Saturn are a little further down past Venus. I don't think you'll be able to see them, but you might. Looking for.
Yeah, it's a kind of a non-visible grand alignment. We've had several of those in the planets up at night, but they are all right next to the sun, which means that they're still there, right? Because the light of the sun overwhelms our being able to see it, except in sort of rare conditions. Then the eclipse gives us this wondrous opportunity that here in the middle of the day, actually one of the ways that they use to validate relativity, because they could look where the stars were in a path near the sun and the amount of gravitation of the light compared to when they were looking at those same from the other side of the orbit, not looking through the gravity of the sun. And so they went, Einstein was right after all, and he became a rock star in physics then.
He did.
When Pastor Reichert was explaining how this eclipse works, he mentioned 2 different 1 to 400 ratios, and I'm thinking, is there some reason for that? Is just a coincidence, or is there something?
just, little piece of trivia, the moon's orbit is gradually, very slowly getting larger. And in about 600 million years, it won't be big enough to ever cover the whole disk of the sun, and we won't have any more total eclipses. So if you're going to wait around that long, you better see this one, I guess, is the moral.
Well, that probably I'm on, right?
I couldn't help but notice that the planets are not listed in the creation story. And I wonder if they are mentioned anywhere in the Bible, because it seems to me that the planets were not really discovered until several thousand. And I mean, they were there. They knew there were. They probably called them stars. They were so. But anyway, so just a thought.
The word planet comes from a word that means wanderer. And it was that those stars, rather fixed as they moved through the seasons, you could count on Orion coming up and looking like Orion, that just were wandering. And that's where the term planet came from. And then as our understanding, particularly at the invention of the telescope, Galileo and a couple other people looking through those early telescopes in the early, they saw a disk with features, and they realized like the moon was a sphere, and that they must not be that. Constructing models of how that worked, and that's where you had the models of how the solar system worked, and when the big fights that happened between the church and science, between geocentric or Earth solar system. Yep. There's somebody over here. Yeah. Burn out your camera.
During totality, it's safe, but
Yeah.
any time before that, or
You
after.
could take it right through the glasses.
And I would recommend, Google that, because you'll get some good advice about how to do it. And I've even read that there are phone apps that you can get that will help you with the focus and the exposure time to get that right. So I don't have information out there that might help you get a better picture. It's a great question. So, well, I don't know if this will help. I've got a model moon to help you get a sense of the scale of this. And the bottom line is that as the moon orbits the Earth, it's not a bit higher, and sometimes it's a little bit lower, and so the shadow misses the Earth. The alignment is perfect when the moon is, for us, a new moon, or on the opposite side, a full moon. So during those 2 times of the year, and it's not exactly 6 months apart, so it varies a little bit from year to year, but only during those eclipse seasons do we get eclipses. And there has to be at least 1 lunar eclipse and 1 solar eclipse every year. You have 4 eclipses a year, and sometimes it's 5.
Eclipses regularly. If you were And we talked about it not just being the size, but it's also right. The International Space Station has a solar. They go around to the night side. They're not on the planet, so it's not actually night, but they are on the night side of the Earth. And so the Earth's shadow blocks out every orbit, which is why they had to develop some really cool batteries. It was all from solar power in the space station. And they 16 times a day, half of those hours are dark.
I heard that like animals might be affected by the eclipse and your pets and birds and things, and I wondered if you could say anything about that.
Professor Laird has actually been in an eclipse, so.
The answer is yes. That we saw 7 years ago, we noticed the insects. Animals tend to respond to that. So insects and birds have clearly been observed doing that. Mammals respond as well, but I don't think that, partly because the eclipses are rare and it's hard to get to one, so doing that kind of study is hard to do. But I would certainly not be at all surprised, or larger animals, farm animals and so forth, reacted as well.
You know, veterinarians are recommending that if you can keep your dogs and cats inside, because they are more likely to on with you, and so they may look and that could hurt their eyes. So to keep
you are reacting, they may react to you reacting.
Could you repeat the time of the eclipse again? Starts, and then like when we have the totality, and then to the end.
Sure. And it lasts until about 4:30, and that's from the first bite of the moon out of the disk of the sun until it leaves it, and then from about 3:10 to 3:14 in that window, depending really a lot on at this part, because you are north or south, it starts taking a lot of seconds off of the amount of time of totality. But about 3:10 should be a few minutes.
Follow up on that.
Yeah.
When it begins, if you're outside and you're going to look up in the sky.
Something filtering your vision. Yeah.
During this eclipse. So
Anytime. Yeah. Yeah. Exactly. Exactly.
So to be clear, the sky itself, of looking up and looking around, that kind of stuff.
Yeah, to get a sense of much that natural response of kind of veering away, which cuts about 90% of the light down, particularly if the moon is full, because it's so much light, it hurts my eyes.
I've got two questions. Number one, I think there's going to be a way up in the flight levels. We're talking 50,000 feet during this thing, so they can get some data from that.
Yeah, the idea is to chase it,
Sure.
right? Because the shadow's moving so fast at any one spot. you can extend the time that you're in the shadow.
Supersonic plane is, okay, because I was
I
wondering if
assume
they,
so. I don't know how fast
if they
can
had
go.
if they had a, special exemption from the fact that you can't fly, supersonic over, over land.
There are several 737s that are outfitted with scopes. It's one of the main ways that they used to do infrared. Here tamps down the amount of infrared that you can see, which is why we have the Webb Space Telescope up there, and Compton before that. That you can if you're doing any kind of infrared.
And my number 2, can you explain contacts? Can you explain those? There's like 4 or something?
Mm-hmm. Yeah. So first contact is when the moon first touches the disk of the sun. That's first contact. Second is when the backside of the moon has passed that first edge of the sun. See if I can do this, right? So that's first contact, that's second contact. Third is when this edge passes this edge, and fourth is when it's just
Beginning and end of totality.
right. So first is you're paying attention to that front edge of the sun. So one contact from the moon and the second contact from the moon. Trailing edge of the sun, third contact, fourth contact.
When it's not a total solar eclipse, because there are other kinds of transits of Venus that happened fairly recently, just about in the last Venus go across. Well, the disk of Venus only takes up like a pencil eraser of your. Those contacts were much more spread apart time-wise.
An open area. Do you have any recommendations, oak openings or some place where it would be a really good place to view it?
The light dome over the cities really diminishes what's. The sun is just so much brighter that event not going to be impeded. It's happening at 3 in the afternoon too, so it's going.
The street lights won't come on when it gets dark?
They might vision of it.
Yeah, it won't bother you at all. Any place you can is going to be just fine. I will, I'll invite you down to BGSU. They'll have, activities for in case it's cloudy, there will be a live stream from other places. But there's driveway. That's one of the nice things about a solar eclipse.
I would urge you, because some of you may be tempted to try and get a better look at what's going on. So handy to look. You need to cover the sunward lens with some filter, not just look with your eclipse glasses on with the binoculars, because that will be the leaf. It will just burn a hole right through them.
Yeah, so eclipse glasses in the very front of the binoculars, not at your eyes, except during totality, and then it's safe to use the binoculars normally.
44.
45, really. There's one in 2044 that will just hit northern Montana that, goes from northern California to Florida. Anxious to see it again. I hadn't until 7 years ago. And it is such a unique experience. It's kind of surreal. It was pointed out to me later. Starting to get dark. The sun is very low in the sky, so we're used to seeing long shadows. So we see that kind of reddish hue and these long shadows, but midday it's getting darker, but you have short shadows, light, and I noticed it at the time. There was something wrong. I couldn't put my finger on it. It was reacting somehow to that. I know what's normal, and this wasn't normal. And the reaction of around you, and it's odd. And of course, looking at the sun, which is just, seeing the corona is really something else that I'm very much looking forward to again.
There are people who've seen like a dozen, but to do that, you have to be able to go anywhere in the world or on cruises or things like that, because a lot of times the shadow of the eclipse is bounded spot in the ocean, and you have to be like in the right spot, right, to be able to see it.
In fact, we're quite fortunate even to have, these 6 and 2024 and 2099. I saw results. They fall on the Earth. And it turns out that the average time for a given spot between seeing total solar eclipses is over 350 years. And if you live in Carbondale, Illinois, that was on the center line of the eclipse in 2017. So they got 2 in.
We are about out of time.
We've got
a couple more questions.
The U.S. than when it has come across? In other words, this one's going from southwest to
Yes, there is. The moon is in its orbit, how it's moving. One of the interesting things is that the geometry repeats in a regular pattern of 18. And that means that this eclipse will be replicated in 18 1/3 years. Now, because the Earth's rotation, it won't happen here, it'll happen 120 degrees around the globe. And in 50, but it will, in this case, be further north. Is the moon sometimes further away? Is it a little bit too low or a little bit too high? So those 3 things factor together to make the geometry very complicated. And that's why it's
a lot of them in this area happen in the spring or the fall, but there are other places in the world where they happen at other times too, and that makes the geometry even. You can have a very different kind of pattern, something orbiting.
Designated dark sky
because there's one in, my wife's gone. Yeah, that's what I was trying to remember, whether it's Nevada or Utah or Colorado or, but population density is lower there. You can find spots where there aren't cities within, a couple hundred miles.
Yeah, if you look a nighttime image of the U.S., the lights from the East Coast there are pockets where it's less, but really it is light. There are these big patches that are much, much darker, just because there are so many few people.
And even in Northwest Ohio, you can get away far enough away from Toledo and you can find places like that. It takes a little bit of work to do. You got to really.
A good-sized lake, it doesn't have to be Lake Erie, but a good-sized inland lake. There are a number of larger lakes. If you are out on a dock on those, most of them are not surrounded by a town, and because you've got a mile or so, several miles.
Coast, Hocking Hills, other places like that, just out in the boonies. It's really nothing like.
5 minutes.
5 more minutes. We have almost enough empty tables.
General astronomy questions, too.
I came in late, so I don't know, maybe you already said this. I had heard that you'd be able to see the sunset like 360 degrees. Not just in the west.
Oh, I see what you mean. You would see the sky appearing that, where the sunlight is actually getting down to the ground is going to be a little bit sense of that dusk, like sunset is, because the sunlight's not being filtered through a lot of atmosphere as it is near sunset or sunrise, but it will of the sky.
And here,
That's what you were.
because we're always to the south of us, and so usually at sunset the north is dark and south. The north, because Sylvania will be light, right? So as you look north, you will see the light there brighter than you will see it looking south. When you look through your eclipse glasses right now, it looks black. Parking lot with your glasses on and look up, you will see the sun. It looks black because it cuts that much light. So little light that it's safe to look at the sun. We are not operating in that much light all the time.
In other words, don't wear these glasses when you're driving
your car. No. And like Dr. Laird said, that sun, it darkens the amount of light in, actually opens up your pupils, and you are at risk, if you just use sunglasses, more damage than if you didn't have any glasses on, which is sort of counterintuitive. So.
Well, the corona of the sun is the main thing that we now get, and instruments that will, that have a disk in them to block out, but it's not the same thing, especially with the light coming through the atmosphere that kind of scatters it around. Because it's a unique opportunity to do that, we try to take surprisingly simple things that we don't know. For instance, it's extremely hot. It's a couple million degrees, much hotter than the surface of the sun. Well, why? We don't know. We don't really understand how that works. The magnetic field of the sun, some of you know there's greater numbers and then lesser numbers over an 11-year span. It just goes up and down. Well, the whole magnetic field is changing. And we see that in the corona. You can see streamers coming out. It's got the same pattern as the iron filings around a bar. It's got that, that kind of shape. Because the particles are following the sun's magnetic field, we don't understand that 11-year cycle very well either. And the corona is giving us some clues about that. Also study the upper atmosphere of the Earth, because the sunlight coming in, especially the ultraviolet that doesn't reach the ground, but it's ionizing air molecules at that's important to us for some kinds of radio communications, for instance. We bounce signals off that layer. Light, you get a chance to see how does the atmosphere respond to that cutting off of sun. It helps us understand much better how the upper atmosphere works, and it is important to us in a variety of ways. So those are some of the main things astronomers are interested in. If I were a biologist, I'd go after the animal behavior, for example, but,
So is the corona basically the atmosphere of the sun?
Mm-hmm. It's the outer atmosphere. They're kind of three. The bright surface is the lowest layer. Then and you might be able to see the red color. That's the second layer, and then the corona, very large outer layer. But very, very hot and still glowing. Didn't hear it. S-I-O?
Organization that's probably printed on your glasses. Things that to qualify for certain things has to block a certain amount of light. Kinds of equipment have things that standard as part of it, but it's not just Eclipse glasses.
That's important because, believe it or not, that don't meet that standard.
Right. And we made sure that we got NASA approved glasses so that they would be the most safe kind. Yes.
So first of all, Carl said the food's ready. I know that in the article it said what your first experience was with that sparked your interest in astronomy. Dr. Laird's, what his first experience was as a kid.
I saw Saturn through a telescope in 9th grade. And, small image, but it looked like the pictures. And it just was, that stuck with me for a long time. And I had in 9th grade science a 6-week unit on, I kept that, but I didn't have any more formal experience with astronomy until I hit college. And I just thought astronomy, that's what I've followed since.
you ever go to a star and Saturn is visible? It's the thing, really. People see that, and almost invariably there's a gasp because it's incredible. Great on the NASA, but like if you look at the Ring Nebula, which is a pretty famous deep sky object, like it looks like a slightly greenish smoke ring that's like not very impressive to look at, and depending on the amount of light in the sky, you can't even look straight at it. You have to use averted vision. It's just people, when they're looking for those kind of things or looking for like the incredibly beautiful from the Eagle Nebula and Serpents. You can see that it's there. But it's nothing like when, that was the thing, when Hubble went up, particularly after they had before. We used to have artists' rendition of deep sky objects, and now the actual, just have, the detail is incredible. And the stuff that's coming out is, oh goodness. 2.4 meters, and able to see more things and farther back in time. General astronomy thing. A lot of people, when they are buying a scope because they want to look at something, that doesn't help you nearly so much as aperture. Lens or mirror that you're bringing the light into, because think about the size. You had a pupil that was at the sky, the Hubble Deep Field that was first done in 1995. Planned this project for a year, really anticipating that it was going to fail miserably, but they aimed it at a pinhead just north of the Big Dipper. So just above the Big Dipper, just darkness. And they looked at that for 10 days, at that nothing. Tens of thousands of galaxies, billions of stars in them. That everywhere you look in the sky, everywhere you look, is full of galaxies. I think is approaching 1 trillion galaxies in the universe. Well, 1 trillion galaxies, which have somewhere between 100 billion and 500 billion stars in them. So just the numbers are staggering.
They're astronomical.
All right, thank you so much for being here.
Thank you. I'm good.
I'm good for round 2.
Are you good?
Yeah.
Okay, do you need to eat first?
Thank you, Derek.
No, I'm good.
Okay, I'll make an announcement that.
Keep it somewhere.
You still got it.
Thank you.
Not mine.
I told John, we got to work on your scale if you're going to do the solar system in here.
Yeah.
Yeah, I should say so. This is Sarah. Nice to meet you.
So good to meet you.
Thank you so much.
Thank you for coming. I'm glad you're here.
A great conversation with you.
Yeah, I enjoyed that a lot. I
haven't seen it yet.
I touched on just like all the different faith traditions and what they kind of think about the books.
Yeah.
Yeah, so I wonder that it inspired me.
Fantastic.
Megan, she's nice.
Hi there. So good to meet you.
And sorry, you are.
Megan.
Hi, Megan.
We actually may have met at some point. I was at BG in the Science and Math section.
Oh, then I bet we did. Oh, that's fantastic. And so what's your role now? What are you doing?
So I actually teach science at St. Joseph's Millie.
Wonderful. And what grade?
6, 7, 8. So
Oh,
we
wow.
talk about a lot. I've been talking about the eclipse the past couple of years when we talk about the sun, the earth, and the moon in 7th grade. So very exciting thing.
I am so impressed with people who can teach at that grade level. And especially science. It's so important to do a good job with science
It's
there.
really fun. I pull out like my models. I've got earth, moon, and sun models, and then I make the kids like go around and talk about like why it is, and like take the moon and like move it around so they can actually see. Oh yeah, I can see something different here than there.
Yeah, that's great. That's great. Oh, I'm so glad. So did you go straight to St. Joseph's after graduating?
I did, yes.
So you must have been there for a little while by now.
Yes, I think I'm in my 5th year at this point.
Yeah.
So
Congratulations.
That's fantastic. That's fantastic.
I'm gonna be down there chicken. I don't know
Oh,
if you saw
great.
Seneca County is doing like 150 people are getting married or renewing their wedding vows during the eclipse. So I'm gonna be down there covering that. So that'll be exciting.
I hope so.
Yeah, it'll be like close to 4 minutes.
Yeah.
So that's
Yeah.
a lot
You
better
gotta-
than the parking lot at the plane.
Yeah.
Well,
Yeah.
that's true. You're not going
Parking
to do
lot
very
blade,
well
you
at
get
the
like a
plate.
minute, right? Yeah, we were driving on the 23 side of 475 the other day, and we were like, okay, and we have now crossed where there's not going to be totality anymore. It is fun.
In the little tiny sliver of Michigan.
Is the weather supposed to be good in
Improving
Bloomington?
dramatically. Yeah.
I mean, here it's
and
looking pretty
yeah.
good. Certainly better than one would have guessed.
Yeah, a
Better
week
than the
ago it was
odds.
going to be rain all day, and I was like, no! The curse of Ohio and astronomy,
I was planning on driving east because my brother's in Cleveland, so we were going to meet kind of halfway. But I'm like, it's kind of cloudy that way. Maybe we just
Yeah, I would stay-
closer
Yeah.
to Toledo because it's supposed to be more sunny.
Yeah, because it's just supposed to be clearing out that morning, really. So, but Cleveland won't be quite clear yet, I think.
south to Upper Sandusky, it's going to be right about
That's
in the
right
middle
near
of
the
it.
center line. Yeah.
When did you become so knowledgeable about astrophysics?
Yeah, you know so much.
Now you're going to talk to me about elliptical planes?
I've just loved it for a very long time, and so my brain just holds on to knowledge like that. It just sticks.
Okay,
So
you're going to talk about the angle of the Earth's rotation and then the little nutations that happen?
for a section, yep.
Yeah, that too. There's a couple other things going on.
It's really complicated.
Yeah.
I took that class. Okay, it was a TU.
The fact that you call it TU instead of UT
That's
says
when.
something about when you were there. No excuse needed. Yeah, I'm really impressed with the people who do the calculations for the eclipses. And there's a now retired NASA scientist named Fred Espenak who does this stuff. You go to MrEclipse.com, and that's his site. But they do these calculations so that, thousands of years into the past and into the future that are of decreasing reliability, but still pretty reliable way out.
Expanding, so it's moving.
Well, everything's moving all the time.
It's
Yeah.
just not this circular business. The whole thing is moving.
Yep.
That's why it's fantastic.
And
Yeah.
they do.
And they do, and I'm so impressed that they do.